Hello everyone, so here are your notes for 10.2, Finding Arc Measure, Part 1. So let's go ahead and let's first define a couple of more terms. The first one that we're going to go over is the central angle. Now, the definition of the central angle is super straightforward. It is an angle, of course, whose vertex is the center of the circle. All right, so a small reminder as to what a vertex is. If you have an angle like so, the vertex is going to be the point where your two line segments intersect. It's kind of like where your angle begins. So this point right here is the vertex. Now, when we go ahead and apply that to our circle, first we're going to have an angle. So I'm going to go ahead and connect B and A with a segment, and then I'm going to draw another radius and call that radius AC. And now we have an angle where the vertex is in the center at point A. So this right here is our central angle. How we name it, we do need to use 3 letters. It's been a while since we've done this, so let's remind ourselves how that works. We start from one endpoint of the angle, and then we go ahead and go to the vertex next, and then finish up at the last endpoint. In other words, I went ahead and started at B, went to the vertex, and out to C. If you start at one of the spots in your angle, and you trace it to the vertex, and then back out again, that is the order that you will use to label your angle. I can, of course, go backwards and call this angle CAB as well. All right, now we have 2 arcs to worry about. There is one called a minor arc, and there's another one called the major arc. Now for the minor arc, this is an arc on the interior of the central angle. So let's go ahead and let's draw a central angle. Once more, I'm going to connect A with B and draw an radius out from A. Call this point on the circle C. All right, and then the part of the circle that is on the interior of the angle, so that's this piece right here, that is our minor arc. Now, kind of 2 ways to see this. If you are familiar with the game Pac-Man, you can think of the central angle as his mouth, and the piece of the circle that he's trying to eat is our minor arc. Another way to see this is as a pizza slice, and the arc, or the minor arc, is the crust of that single pizza slice. All right, so this right here is our minor arc. How do we name this minor arc? To name minor arcs, typically we just use 2 letters that are the endpoints of the arc, and then we draw a little arc on top like so. Now, keep in mind that when we are traveling along the circle or traveling along these arcs, if I say arc BC, I'm referring to the shortest pathway that will get me from point B to point C. I'm not going to go the roundabout way that takes longer, because that's not how we typically define arcs, or segments for that matter. We always take the shortest route possible, which goes directly from B to C. And of course, we can also name it the other way around. We can name it arc CB as well. All right, now for the major arc, it's really just the opposite of the minor arc. So this is another arc on the exterior now. Of the central angle. All right, and of course the exterior of the angle is quite literally the area or the part that is outside of the angle. So any parts of the circle that lie on the outside of the central angle is considered the major arc. Now, the thing with naming the major arc is this. I cannot call it arc BC because I already have the minor arc that's called BC. And so if we were to also call it the major arc the same name, I wouldn't know which arc you're talking about. So in order to avoid that or get past that problem, we simply just put another point on that arc. I'm going to call this point D. And now, when I name the arc, I'm going to use all 3 points. I'm going to go from B to D, and then finally end back up at C. So if we say arc BC, again, we take the shortest pathway. But if I say arc BDC, you have to go from B and then to D, and then finally to C. So when we trace along that pathway, we are tracing along the major arc just like we wanted. All right, so this right here is the major arc. And to name it again, we use 3 letters. So BDC or CDB if you want to go backwards. Either one will work. All right, the last type of arc here is a semicircle. Now, some of you may or may not have used this word before. I think that a lot of us have, though. A semicircle is just a part of the circle. But to be more specifically, it is half of the circle, right? Or a half circle, as many people like to say. So, the true definition, though, is that this is an arc with endpoints on the diameter. Now, why is it the diameter? Let me zoom in and show you. So let's suppose we have just a random line that cuts our circle into 2 parts. Now, if I take a look at those 2 parts, I have a piece down here and I have another piece of the circle on top. These 2 pieces are very different in size, right? The piece on the bottom is definitely smaller than the piece on the top. So when we have any old line that passes through the circle, it might not necessarily cut it in half. However, what I do have is I have a diameter, and the diameter passes directly through the center. And because it passes directly through the center, from one side of the circle to the other, it is in a way cutting our circle in half. So once it does that, then the arc that gets created, this is our semicircle. Not the diameter, but the arc. Okay. All right, and then to name the semicircle, typically we're going to go and we're going to use 3 letters as well because there are technically always 2 semicircles in a whole circle, right? Because I have another one down over here. So in order to be able to figure out which one we're working with, make sure to add on a 3rd point so that we know exactly which semicircle we are working with. So I have arc BDC, or again, arc CDB will work as well. All right, so that is all of the parts or the arcs that we're going to cover. Let's go ahead and let's actually start figuring out how to find the measures of these arcs. All right, so to find the arc measures of the minor arc, the major arc and the semicircle, here's what we're going to do. First, we're going to go ahead and we have the circle, and it has a central angle LKM. Again, this simply just means that angle LKM has the vertex on the center. In the picture, they also tell us that angle LKM is 50 degrees. We're going to go ahead and use that in just a moment. Now, to find the measure of the minor arc, this one is super straightforward. This one is simply the measure of the central angle. So if you know what the measure of the central angle is, then we also know what the measure of the minor arc is. Now, going over to the picture, our minor arc is again on the interior of the central angle. So that's going to be arc LM. And to find the measure of arc LM, we need to take a look at the measure of angle LKM. All right, and we know that the measure of angle LKM is 50 degrees, which means that the measure of arc LM is also equal to 50 degrees as well. Now, something to keep in mind in terms of the minor arc measure is that the minor arc measure is always less than 180 degrees. Right? So if you take a look at the definitions for minor and major, minor meaning less or least, and then major meaning larger, more importance, that sort of thing. So because this is less or least, it means less or least than 180 degrees. And of course, that means the opposite will be true for major arc, but we'll get there in just a moment. Now, to find the measure of the major arc, here's something that we actually have to know. When we have a circle, if we were to rotate from point L and rotate around the circle or go around the circle and come back to point L, this is actually a full rotation or going around in one circle. That is 360 degrees. So let's go ahead and let's make a note of that. One full rotation around the circle is 360 degrees. Now, the major arc in this picture here is arc LQM. And if I were to say add arc LQM with the arc LM, that's already a minor arc, we should get a total of 360 degrees because that completes one full rotation. So if I want to find the measure of the major arc, well, then what I need to do is I need to take 360 degrees and subtract out the measure of the minor arc. So the major arc here, again, we can go ahead and start at L. We go around the circle to Q, and then we finish at M. So that's how we name that major arc, arc LQM. And that measure is equal to 360 degrees minus the measure of arc LM. Substituting in all of the values that we know, 360 degrees minus 50 degrees gives us that the major arc measure, or rather the measure of arc LQM, is 310 degrees. All right, and again, something to keep in mind is the fact that all the measures of the major arcs is going to be greater than 180 degrees. So minor arcs are less than 180 degrees. Major arcs are greater than 180 degrees. All right, last but not least, we have the semicircle. But again, the semicircle is, again, quite literally half of a circle, or a half circle. So because this is the case, a full circle, a full rotation is 360 degrees. We divide that by 2. And so all semicircles are equal to 180 degrees. All right, so that is all of our arc measures defined. Let's go ahead and let's use these in an example. All right, so in the problem here, example 1, they want us to find the measure of each arc of circle P. And they tell us where segment RT is a diameter. All right, so we'll get to that in just a moment. But first, let's go ahead and let's take a look at the arcs they want us to find the measure of. Arc A is arc RS. So to find the measure of arc RS, well, we first have to figure out where that is. So we start at R, and we trace our way along until we get to S, the shortest distance, the shortest route possible, straight from R to S. Now, taking a look at this picture, I can quickly identify that this arc is on the interior of the central angle, angle SPR or angle RPS, however you want to name it. Because this is the case, I now can determine that arc RS is a minor arc. And because of this, we know that the minor arc, the measure of the minor arc, is equal to the central angle. And the central angle is 110 degrees, right? The central angle is here. It's 110 degrees, which means that so must the measure of arc RS. All right. And then now let's take a look at part B. Part B says to find the measure of the arc RTS. So, tracing it out first, we start from R, but we want to go ahead and head towards T because that's the next letter in the name. So I'm going to go in this direction now towards T, and then I'm going to finish at S. Oh, this was on the exterior of the central angle provided here, and it also completes the circle. So this arc right here is actually a major arc. And we know that if we have a major arc, then to find the measure of that major arc, we need to go ahead and take 360 degrees and subtract out the minor arc from that. And the minor arc here is arc RS. So again, substituting in the values that we need or have, 360 degrees minus 110 degrees. This gives us 250 degrees for the measure of arc RTS. All right, now the last one here, it says arc RST. So if I were to go ahead and, again, trace out the arc in the circle, I start at R, I make my way to S, and then finish at T. Notice how it's different from part B of this problem. Part B said to go from R, and then to S, and then to T. But part C says R, and then S, and then T. So following that route, this is what we get. And from the problem, they tell us that segment RT is a diameter. So if segment RT is a diameter, and because the arc here starts at the diameter but also ends on the other side of the diameter, this means that that arc RST is a semicircle. And because it's a semicircle, this means that the measure of arc RST is equal to 180 degrees. All right, so that is how you find the measure for all three of these. All right, so go ahead and pause the video here and see if you can give this one a try on your own. All right, so go ahead and double check over your answers. Now, a few things to keep in mind because this problem is a little bit different from the last one. First of all, arc PL is over here. Now, the central angle that is given, though, is angle LKM. So we run into a dilemma because I have the measure for arc LM, but I don't know the measure for arc PL. However, in the problem, they tell us that segment PM is a diameter. It's a straight line segment. So what that means is that angle LKM, which is 73 degrees, if I add it together with angle PKL, this should equal 180 degrees. So that's what I needed to do to solve for the measure of angle PKL here. When we finish solving, we find that the measure of PKL is 107 degrees, which means that the measure of arc PL is 107 degrees as well. Now, arc LQM, when you trace it, it is this blue arc on the outside. Now, that's obviously not the arc. The arc is the actual circle itself, but I needed to make sure that I didn't overlap to confuse anybody. So arc LQM is this large major arc on the outside here. Now, the minor arc, though, that I need to subtract out is the kind of like the missing piece of the circle. That arc is LM, and again, arc LM is 73 degrees. So subtracting that from 360 degrees, we get 287 degrees. Last but not least, arc PQM, when you trace it all the way around, it starts at one end of the diameter and finishes at the other end. So we have a semicircle, therefore, measure of arc PQM is 180 degrees. All right, so that is it for 10.2 Finding Arc Measures Part 1. Thank you very much for watching.